Okay, it seems as though my fan can be heard a little bit. Uh, so hopefully it's not too bad. Um, yeah, I guess I'll watch it through, and then if it's not too bad, I'll still upload it. But if it's kind of bad, I'll just uh re-record it. Anyways, actually, wait, I'll just turn it down. I'll be right back. All right, so it has been turned down, and there are no more noises to be heard of. All right, nice. Anyways, um. So now apparently this is the next question from Grokking the coding interview. And well, this is very similar to what we did yesterday with the it's like a list and list or something like that. And you just want to find the kth smallest element. Oh no, I think it was just like yeah, I think it was that. I think. Let me see. So if I would go to YouTube, my channel, well not my channel. Um for content, uh kth smallest number in M sorted list. It's literally the same thing, actually. So yeah, but I guess for me technically it's just a free day because I do one of these a day. But since it's exactly the same, we'll we can just read the question. I guess that one's kind of different because that one wasn't on Leetcode, and so I guess it's just to check that we know our stuff. So we have the problem: kth smallest element in a sorted matrix. Given an n times n matrix where each of the rows and columns are sorted in ascending order, return the kth smallest element in the matrix. Note that it is the kth smallest element in the sorted order, not the kth distinct element. You must find a solution with a memory complexity better than O of n squared, and you have the matrix. So since we're doing the same thing as yesterday, we're going to use heap queue. We're going to create a heap, right? We're going to do for I in range of length of matrix. We're going to, whoops, I don't want to create a string. We're going to do a heap push onto the heap. We're going to do a matrix I0 because that's the first value that we want. Index, list index of 0, and we're going to push I as the index of the list. So basically we'll create, for example, with this matrix, we will create a heap with basically 1 0 and then 0 10 10 0 1 12 0 12 0 2, right? So that's what our heap is going to be, and it's be sorted off the first numbers, right? And then so what we're going to do here is we're going to have a variable called popped off, which is equal to 0 first. It's just to see how many numbers we've popped off in order for us to hit this number k, right? So while there's stuff in our heap, we're going to pop things off, right? So we're going to have the number index and list index. We're going to pop it off the heap. So I guess maybe, you can choose better words for this, but at least for me, it works. The index is whatever index we're currently at within the list, and list index is the index of the list within the matrix. So that makes sense for me. Maybe you could use other variables if you want. Not pooped, popped off plus equals 1 because we just popped off an extra number, right? And now if popped off is equal to k, then we're just going to return number because that's the kth smallest number, and we just return the number. Otherwise, if it's not, then if index plus 1 is less than the length of matrix list index, then we know that we have to heap push because we still have more numbers in our list. We're going to push back onto the heap matrix list index plus 1 to get the value. We're going to give it index plus 1 for that, and list index always stays the same. And then so we'll just keep going until we do find this number, and if we don't, we'll just do a return -1 just so we have a number to return when it if we don't ever find the kth number. Like, let's just say there's not enough numbers to meet that or whatever. So yeah, we'll be submitting this, and then it runs. So yeah, that being said, thank you for watching.